All right. Think we'll go ahead and get started now. So thank you everybody for joining today's Unity Catalog workshop. This is a 90-minute session where we'll be giving you an overview of Unity Catalog as well as going through demos. And I'm joined by my co-host Suzanne today, so I'll pass it off to Suzanne to kick us off.
Thank you so much, Pamela. So Pamela and I will be presenting today's workshop. And as Pamela mentioned, we're going to be joined by some great SMEs and supporters in the Q&A chat. So we have Seven, Ankit, Paolo, Frank, Sachin, and Riley. So feel free to add your questions to the Q&A and they'll be supporting you throughout. So just some housekeeping items. Your connection will be muted throughout the webinar. So please add your questions to the Q&A when you have any, and we'll have our SMEs help out there. And we'll be recording and sending out the slides in this session within the next 1 to 2 days. So don't worry if you don't catch everything. You'll get this offline for your review. So I first want to start with announcing that Unity Catalog is now open source. Since the Data and AI Summit in June, we announced this really great new update. And what this means is that you now have full interoperability across major big data formats and engines and native APIs to use with Unity Catalog. And Pamela, we will be presenting those today. In Databricks, Unity Catalog is really the governance layer across all of your data and AI assets. It's super important for managing all of your data, and it powers the Databricks IQ intelligence engine within the platform, which we'll see throughout the demo, gives you a lot of intelligence in accessing and searchability of your data. So let's start off by talking about how Unity Catalog fits into your cloud provider ecosystem. So some of the top questions we get in Unity Catalog deployments is, how does Unity Catalog fit into my cloud deployment? And how should I think about user roles that interact with Unity Catalog? On this slide, we can see how the Databricks account aligns with your cloud provider's architecture. In AWS, the Databricks E2 account aligns with your AWS account. In Azure, it aligns to your Azure AD tenant, and in GCP, it aligns to your organization. On the next slide, we're going to go into a little bit more about the different roles and hierarchies within Databricks permissioning model. At the top, we have our account admin. The account admin has access to that Databricks account that we saw aligning with various components of your cloud infrastructure. The account admin is the most privileged role within Databricks. It has access to creating workspaces, and it can also create and remove any Unity Catalog metastores as well. We recommend that this role is allocated to a central governance team or a platform ops team to ensure that there is proper permissioning and also any rights provided. At the workspace level, we have the workspace admin role. The workspace admin role similarly is the most privileged role within the workspace. They're able to create any clusters, put permissions on various assets within your workspace, such as notebooks, and they can also add and turn on any features within the workspace. This is also recommended to be not an individual role, but to be allocated instead to a group that aligns with your organization's procedures for management. So for instance, an IT platform or DevOps team would be best suited for this role. Underneath the workspace admin, we have the least privileged role, which is an account user, is just anyone in the Databricks account who can use a workspace. Within Unity Catalog, we have two main roles. We have the Unity Catalog Metastore admin, and we also have the marketplace, which we'll touch on later. The Metastore admin is your account admin type most privileged role of the Unity Catalog Metastore. This role can create and remove any metastores and is responsible for setting them up. Additionally, this role should be allocated to a group with higher privileges, such as a platform ops or central governance team. Underneath the Metastore admin role, we have a few other roles. The catalog owner is the next privileged role, and this person is responsible for managing any catalogs and underlying schemas and objects within a catalog. You can set this person up to be different than the Metastore owner. And for instance, you can set them up to be different domain owners or different business owners, depending on how you organize your data. A schema owner is a less privileged role, and this is someone who's responsible for owning a schema and all the underlying data and AI assets in there. And then the least privileged role is a table or view owner, and there's other subsets of permissions as well, such as viewer. Within the Databricks marketplace, we have a marketplace admin. This is a parallel role to the Metastore admin, and this person is responsible for setting up any shares in the Databricks marketplace. And underneath that, you have your marketplace user. The main takeaway between all of these roles is that there is a different hierarchy of roles, and we recommend using the principle of least privilege when allocating them to different individuals and groups. And most importantly, you should not allocate a lot of these roles to individuals, but instead allocate them to groups. Taking a deeper look at how these roles align with unitycatalog, on this page, we can see that the Metastore admin is responsible for the Metastore, as well as other objects within unitycatalog, such as your storage credential, any Delta shares, and any external locations. They also have privileges over any of the catalogs within a Metastore. The catalog admin, by example here, is an individual who is responsible for everything within a catalog, so they have a smaller permission and privilege space. So as I mentioned, the best practice is to assign these high privilege roles to groups and not to individuals, and also to make sure that these role assignments align with your organizational governance practices. So let's talk a little bit more about getting started with the Metastore. So some of the top questions we get when setting up a Metastore is, how do I do it? What storage configurations do I need? And what are the best practices for configuration? So if you created your workspace after November 2023, you were more than likely given the option to set up a workspace with a default Metastore setup. What this means is that unitycatalog is turned on by default, but it won't have a managed storage location allocated. And you can have your account admin go into the account console and allocate that for you. This image shows some of the different components of a default Metastore setup. We can see here that there's some default catalogs that come within my workspace. I can also create my own catalog defined for this particular workspace. And most importantly, the workspace admins are the default catalog owners for any of the new catalogs that we create. And we also still maintain support for Hive through the Hive Metastore legacy compatibility. On the other hand, you can also set up a Metastore manually. In a lot of cases, you would want to do that if you have any specific kind of requirements for your Metastore setup, or you created your workspace before November 2023. In this case, you need an account admin to set up your Metastore. In the account console, they'll go to the catalog tab and then create a new Metastore for a particular region. So there's a one Metastore to one region mapping. You can give a specific name, and you can also give a storage location and relevant credentials for connecting to the default managed location that you're setting up for this Metastore. So I mentioned that there's different managed storage locations, but what does that mean? Within unitycatalog, you can actually set up managed storage locations at different levels in the hierarchy of the unitycatalog organization. We talked about setting up the managed storage location for your Metastore, which is what you do within the account console, or you have to set up manually or do when you have a default catalog creation as well. Below that, you can also set up a storage container at the catalog level and also at the schema level. What's important here for you as an admin or as a user is that your data assets and AI assets will be stored at the lowest level where the storage is defined. So what we recommend is that instead of using the default managed storage location for the Metastore, is that you should actually set up storage level or catalog level storage location so that you can segment out your data by catalog. So let me touch on registering and discovering data within unitycatalog. Some of the top questions we get for data creation and discovery is, what are the objects I can store and secure in unitycatalog? What kind of permissions do I need to secure them? How do I best organize my data and AI assets? How does unitycatalog help me with discovering my data and AI assets and improve the productivity of my teams? And what should I be doing to better improve my team's productivity and searchability? So with the introduction of unitycatalog, we now have a 3-level namespace. We have the catalog. Under that, we have a schema. And at the schema level is where we have the level of organization of all of our data and AI assets. That's where you'll store your tables, both external and managed, which we'll touch on the difference between those in a few slides, as well as your AI assets, your models and functions, and any arbitrary files in volumes. Parallel to that, we can set up foreign catalogs, which are set up on external connections through Lakehouse Federation. Additionally, the Hive Metastore is supported within this 3-level namespace with a Hive Metastore catalog set up for legacy compatibility. So as I mentioned, you can store both data and AI assets within unitycatalog. Let's talk a little bit more about what these data assets are. So the first data asset is a storage credential. So a storage credential is now the new way that unitycatalog manages all of your storage permissions. Now you can manage your access controls in unitycatalog, and there's no need for pass-through credentials on the cluster, which was the old way. By setting up a storage credential, you just need to have the IAM roles or managed access to your different external locations. And then this will be used and you can allocate to different storage locations for access through unitycatalog and permission that for your different users. And this is a centralized way of governing for storage credentials. External locations then can be created by using those storage credentials. You can create external locations on different S3 buckets or containers, and then you can use these to store any external assets, such as external tables. You can also reuse a storage credential across many external locations. Volumes is also another data asset within unitycatalog. Volumes is the unitycatalog solution to arbitrary file storage. You can navigate volumes within the unitycatalog UI, and you can navigate it similarly to how you would navigate any kind of file system-based solution. You can set up external, and you can also set up managed volumes within unitycatalog. For an external volume, you need to use an external location. So here in this example, we can see that you can create either a managed volume or an external volume, and by creating the external volume, you're leveraging an external location to store it. So I mentioned a little bit of manage and also external. So the most common element or data asset that you're leveraging in unitycatalog are tables. So there's 2 different types. There's managed tables, and then there's also external tables. The main difference between them that I want you to take note of is that managed tables means that Databricks manages both the metadata and also all of the data stored in your storage location underneath that. So that means that if you drop a table, you not only delete the metadata, but you also delete the underlying data files. For an external table, when you delete or drop a table in unitycatalog, you're just dropping the metadata, and the data and files underlying that get to stay in your external location. The advantage of using managed tables over external locations is that you don't have to handle the data cleanup if you drop a table. And additionally, all managed tables will have a lot of these new features introduced into unitycatalog enabled first before it goes to external tables. For instance, the enablement of predictive optimization does automatic optimizes and also vacuums and cleaning up your files for you so that you don't have to manage and run jobs to do it. Whereas for external tables, you still have to do that setup. So here at Databricks, we recommend that you lead with managed tables, and if needed for other solutions or compatibility, you can leverage external tables, but using managed tables first will give you the best experience. I touched a little bit on foreign catalogs. So Lakehouse Federation is the Databricks solution within unitycatalog, which enables you to have access to external databases directly in unitycatalog and manage them like you would any native or standard unitycatalog asset. Here we can see a list of sources: Snowflake, PostgreSQL, MySQL, etc., and the list is growing. When creating a Lakehouse Federation connection, you can do that directly within unitycatalog. You can set up the connection name, and you have to input also the credentials. In this example, we can see that we're connecting to PostgreSQL. We're giving the host name and port, and we can also store the username and password credentials directly within unitycatalog and only set it once. And we can set up permissions on it, just like how we set up permissions on any other unitycatalog objects. Then step 2 is to give people access to all of the data within these external connections. And we do that by creating a foreign catalog. We can define the catalog name, and we can set up the connection to the external connection that we set up, and then we can give people access to the tables. When people query these tables, they'll only be able to query them based on their privilege set, and then the queries will be pushed down to the external source system. So now let's talk a little bit about AI assets within unitycatalog. So Feature Store is now part of unitycatalog. The advantage of that is that now we have a unified way of managing our feature tables as well as our tables within unitycatalog. And the really cool thing is that any table within unitycatalog that has a primary key defined will be automatically created as a feature table within the Feature Store. And feature tables are really useful in helping accelerate machine learning development by defining these features and cataloging them for people to reuse in their machine learning. Models are another major asset stored now in unitycatalog. Within a schema level, we can save our models and give them different tags and aliases to improve searchability. We also will get access to the version history and all the other metadata associated with models registered in unitycatalog. And we can set permissions just like we set permissions on any other unitycatalog asset. So we can give people access to use the model, or we can deny them access. Another AI asset governed now within unitycatalog are functions. So these are SQL or Python-based functions that we can reuse across different assets within unitycatalog, and we can govern their use using the permissioning model of unitycatalog. You'll see later today in the demo that Pamela will leverage a function and apply that for row and column level filters and masks directly on tables within unitycatalog. Lastly, vector search index is a one-click solution within unitycatalog to support your RAG and GenAI based solutions. What's really cool about this is that within unitycatalog, I can select any table and I can make it into a vector search index by defining what my embedding column is and defining the embedding model. So I can do that directly within unitycatalog, and it'll sync any changes to the source table, generate those embeddings for me, and make it queryable through an endpoint for my RAG applications. So now that we have all these data and AI assets in unitycatalog, what other things can we get? What other advantages are there? So one of my favorite things within unitycatalog is the auto generation of tags and comments. So what we can do here is actually press the AI generate button, which leverages Databricks IQ in the background, and that'll generate any of our comments for our columns and also table descriptions. This is super useful if we want to have people be able to search within unitycatalog and search within the Databricks workspace for any data assets using different keywords. Additionally, we can add tags, and tags make it very easy for searchability within a column or on a table to pull out the different assets that you need based on any kind of tags and filtering criteria. And you can also use these tags in the future for applying different policies on security as well, which Pamela will talk to more. So the best practice is, when setting up your data and AI assets within Databricks, is to add your tags and comments early and often to improve searchability of these assets for your users. As I mentioned, there is improved searchability within unitycatalog. You can do that, or you can take advantage of that by leveraging tags and also by adding in the metadata, either user-generated or using the AI and Databricks IQ built into the platform. This is really great because now I can tag my data and I can pull up any notebooks or other assets that are leveraging this data and be able to have a full view of how it's being used throughout my platform. And what's really cool is that when I'm tagging any of my assets or labeling any of my assets within unitycatalog, I can see its usage across many workspaces, because unitycatalog is not just a workspace finding. Now it's at your account console level. As a data engineer, this is definitely one of the features within unitycatalog that makes me the most excited, and that's automated lineage. Now with all of my data and AI assets within unitycatalog, I get lineage for free. So what's really cool here is that it not only gives me lineage and upstream and downstream relationships at the table level, it also gives it to me at the column level. And I can click through and see that within unitycatalog directly. And now lineage has gotten even better with the build or bring your own lineage preview on today. And so what this allows you to do is bring a more complete view of your lineage on your assets, both upstream to our first mile lineage and downstream, which is our last mile lineage. So now we can get a more complete picture of how my data assets are being leveraged and created. So now with that, I am going to switch over to a demo. So here now I'm in my Databricks workspace. I am just on the catalog page, so you can see all the different catalogs within my Metastore. I have one of my computes running, and this is what I can use to query and see any sample data. Here at the top, I have some different functionalities: delta sharing, clean rooms, external data. I can browse my DBFS, and I can also add data. In this case, I'm going to click on the Create Catalog button. When I press Create Catalog, I can create a new catalog, I can give it a name, and I can create a standard type catalog, a foreign type catalog, and also a shared catalog. And so this shared catalog will then be able to be shareable via delta sharing. Now let me click into my catalog UC Web. In the UC Web catalog, I can see that I have 3 schemas. 2 of them come by default. The default schema is given to you where you can store any data without creating a new schema. And the information schema is where we have some system generated information about your catalog stored there. For instance, any constraints or tags will be stored in the information schema tables that are system generated. Let's click into the Metacare schema, which I created. So within the level of the schema, we can see that those different assets that I talked about, tables, volumes, models, and functions, are all stored here. So let's click into the volumes first. In the volumes, I can see that Pamela has created some files for us. In the volume experience, I can click through, very similar to how I would any file system, and explore any of the assets stored here. And these are where I'm going to store my arbitrary data files and use them for downstream processing. If I click back into my schema, let's look at a table now. So let's look at my CMS cost table. Here in the table, we can see that I have my columns defined, so I can see all the column names. I can see that some of them are defined as foreign keys, some of them are defined as primary keys. I can see the data type of the columns, and I can also see any comments, and I can add tags as well. So let's click on the AI Generate button. So I click the AI Generate button. This triggers Databricks IQ to provide me any kind of metadata that I want for this table For instance, it gave me some comments for this column. I can accept this, and then I can then edit it. And this now improves searchability of my data assets so that I can share them out to any of my users and they can search for the table without having to know the column names or the table names by leveraging the metadata in the comments. So this is super useful and helpful for you as a data owner or a data steward for enabling searchability of your data assets much more quickly. Okay, let's go into the details of the table. So here in the details of the table, I can see that this is a managed table. It could either be a managed or it can be an external table. I can see where it's stored. I can see some of the information about the Delta table properties. And most importantly, I can see that because it's a managed table and predictive optimization has been enabled at the Metastore level, I know that this table will now handle, with predictive optimization enabled, all the vacuum and optimization for me so that I don't have to worry about that because it'll be handling all of that data cleanup for me. So now that we've looked at all of this, let's see how we would do it programmatically. So let me switch over to my workspace and look at my notebook. So in my notebook, here I'm just using plain ANSI SQL to define my catalog and to define my schema. I'm also then creating some of those tables that we looked at, such as CMS costs. I'm defining the schema of the table, and I'm also defining those primary and foreign keys, which we talked about. By defining primary and foreign keys means that it's going to be a feature table by default, and also the foreign keys enable us to create the entity relationship diagram automatically in unitycatalog without having to do anything extra. I also want to point out that I'm creating the CMS drugs table, which I'm defining it, and then I'm also inserting into it data directly from those data files that I looked at in the volumes. So I can do that all within SQL, and then I can set up all of these tables and their permissions on them as well, programmatically and also within the UI. So let's go back to the UI, and I'm going to show you what defining the foreign and primary keys does. So if we go back to our catalog, we go back to our schema, we can see within the CMS costs table that we were looking at, where we defined it in SQL, we now have this button called View Relationships. And this is my entity relationship diagram. So as a data engineer, I remember having to draw these myself, but just by defining the foreign keys and the primary keys within unitycatalog, this is generated for me by mapping them to other tables within my unitycatalog assets, which is super cool and super helpful. And this also, makes it easier if you're trying to onboard new individuals or data engineers to your data in unitycatalog. They don't have to ask you for the ERD because it's already generated for you by you defining the foreign and primary keys. So as I mentioned, since this table has a primary key defined, that means that it's automatically a feature table. So if we go into the features on the sidebar, we can see that all these tables here are defined as feature tables. I can find my table that I have already that we looked at earlier. We can see that it has some tags on it, and I can also see the table comments as well. So this really makes it easy for me to trace tables within unitycatalog to my feature store, and then be able to reuse this table in any machine learning training. So now I've used this table to train a model. It's an input to another feature table, or it's input to a model. So let's go back to unitycatalog, and let's look at the model that uses this table. So if we go into the UC Web schema again, remember this is catalog again, and go to Medicare schema, we can see again all of our assets. Let's go into models. Here we've created a cost model for predicting the cost of different medications. And here, this cost model, I can see all this kind of metadata around the model. So I can see the version of the model, I can add any tags to the model, and I can also add any champion or challenger aliases, and I can manage the permissions of this model directly within unitycatalog. Now I use this model for predictions. So I use this model to create this CMS predictions machine learning table. So here I can see that this table has these various columns. It has my prediction column, and I can click into lineage to see what this table depends on. So looking at my lineage table or lineage graph, I can see that this table depends on an upstream training table. And if I click more here and I click more here, I can see that I get an even more complete picture of the lineage of this table. I can see that it actually depends on a external table on a foreign catalog, which is federated in from Snowflake. And I can see that there's other tables that it depends on. And what's really cool is not only does it show me this at the table level, if I click on my prediction column, I can see how it depends on the upstream table at the column level. So this is really cool for enabling auditability and traceability of your data assets within unitycatalog. And again, I can also manage permissions on this table by going to the permissions tab. I can grant and revoke permissions to different users or to groups. And there's different levels of permissioning so that I can ensure that I'm giving the least privilege required to an individual or a group. So now let's say I want to use this table for any of my RAG applications. I need to set up a vector store index. And as we looked at in the slides, we can do that super easily by pressing create, pressing vector store index. And now I can create a name for my vector store index. So I'm just going to call it CMS predictions, vector store index. I'm going to select a primary key. I'm going to select a serving endpoint. So now I can query my vector store or vector search index for my RAG applications. And I can set up any triggering mode. So I can have it sync whenever I trigger it, or I can have it sync continuously whenever there's any updates to the back end table. And then I can also compute embeddings or use an existing embedding column. And so I can do that all just with a few different clicks within unitycatalog. And then I get a table ready for RAG. Now let's click create. Great, so now I can see that my vector store index has been created, it's provisioning, it's connected to this endpoint, and I know that the underlying source table is that predictions tables that we looked at. And since I set this up to be a continuous sync, it'll keep syncing whenever I run any predictions and update this table. So now that we've done this really quick and comprehensive tour of the unitycatalog functionalities, we looked at data assets, we looked at AI assets, we talked a bit about searchability. I'm going to pass it off to Pamela, who's going to be talking about securing your data.
Yeah, thanks, Suzanne. Let me go ahead and share my screen here. All right, so I'm going to pick up where Suzanne left off, and we'll go through securing your data with unitycatalog. Some of the top questions that we get here are, how do I manage my permissions on my data assets, and how can I apply fine-grained permissions like row-level filtering or column-level masking or attribute-based controls across your unitycatalog objects? So unitycatalog gives you centralized access controls across all of your objects. As you saw in Suzanne's demo, you can apply those grants on top of the whole gamut of unitycatalog objects directly within the UI. But you can also do this programmatically, just using regular SQL to grant any particular privilege on any of the secureable objects to some identity, whether that is an individual user or a group of users. A few next steps that we have here, one of the additional permissions that we have is the browse permission, which will allow your users to understand what assets are potentially available for them to interact with without actually getting access to the underlying data set. And coming soon would be the next step from browse. So if your end users find the UC objects that they're interested in querying against, they can request for access, which could kick off some additional integrations for granting that access, so that the users can start interacting with those data sets once they've discovered them using the browse permission. And then finally, it would be your admins being able to approve those requests coming in for the full complete cycle. Once your users have access to particular assets, you might want to apply additional permissions for both row and column level security. The way that we do this is by creating functions that are registered directly within your Unity Catalog schemas, along with all of your tables and models and all of your other assets. And then you can use those functions to apply the security across particular tables. So you can define a function once and use it across a variety of tables, giving you consistency on how you're managing the row and column level security across your assets. These permissions can also be automated using our APIs and like infrastructure as code framework like Terraform. So let's go ahead and get into a demo here where we can take a look at what the row and column level security setup looks like. So here, just like you saw in the slides there, we're going to go ahead and create two functions. I'm going to create a masking function first that is going to check and see if the user trying to query the table is a member of the HR admin group. And if they're not a member, then they won't be able to see the NPI column. Next, we'll create this row filter function, which is going to check and see if the user is a member of the geo group here. And if they're not a member, then they'll just get limited access to a few states. So we can go ahead and look at the groups that I'm a member of here. So you can see that I am not a member of either of the groups that we outlined here. And before we go ahead and apply any of these functions, let's just take a look at what I can see with these data sets. So when I query against our federated table here for the provider, you can see that I can see the full scope of the numbers for the NPI column. And then if we query against our geography table here, you can see that I can see the full scope of rows across all of the available states. So I'm going to go ahead and alter these tables. First, I'm going to alter my federated table using the function that I created to apply the security there. And then next, I'm going to alter the geography table here to again use that filter function that we just registered and apply it to this table as well. And now when I go ahead and query against those same tables with these functions applied, you can see I can no longer see the NPI information because it's leveraging that masking function. And here, when we go against the geography table, you can see that I'm now limited in the states that I'm able to view, just those 3 states that were outlined in the function above. I can also drop these column masks and row filters as I need, but I'll leave them on for now. If we go to the Catalog Explorer and we go to the tables that we were looking at here, so the geography table right here, you're actually able to see in the table details. Might have to just refresh my my screen here. You're actually able to see the row filters that are applied to this particular table right in the table information. And the same thing goes for that federated catalog that we were looking at. If I look at this table here, I can see the column mask that's applied directly to this row for my federated table. So all of this is great so far. We were able to do this fine-grained access control to our tables, but we want to be able to scale this. And that's where attribute-based access controls come in, which we have a preview for coming soon. And this will give you those scalable policies across all of your data and AI assets using tags, location, identity, or time attributes. So one use case for attribute-based access control might be masking all columns tagged PII. Previously, you could still use the same function, but you'd have to go through and do those alter table commands across all the tables where they have PII. With attribute-based access control, what this will look like in the future is just leveraging a rule that will apply that column mask across all tables when the column is tagged a particular way. And so we're using the attribute, this tagged attribute here, to apply the function that we registered, that column masking function at scale. Another example might be that you only want to grant access for users to interact with objects for a particular time period. And so what that might look like today is some sort of function where you're calculating out and then executing a revoke statement. What this could look like in the future is setting up a rule that will grant access only within a particular time bound. So in this case, we're using the time attributes to determine how the rule will be applied. And then another use case would be denying the ability for owners to manage permissions of particular schemas. So limiting the permissions that users could have. So here it might be, you're giving someone full create schema, and then they're managing that schema and all the assets within it as well once they've created it. In the future, maybe you're allowing that, specifying who manages that schema just to a particular group. All right, so we have all of our permissions. We've granted users access to this data. We've applied our fine-grained security controls. Now we want to be able to have strong observability into how those users are interacting with all of the data assets that we have in our Metastore. So this is primarily all of like the auditing capabilities. We want to understand about usage patterns, configuration regarding the lakehouse. What are, maybe some of the expensive workloads that are running? Are the workloads running efficiently? What are the tables that have been created? Who's interacting with those tables? Maybe even for the data that you're pushing through your pipelines itself, how do you monitor that data and the quality of the models that you've registered within your Metastore? So first, we'll start out with Lakehouse monitoring. Once you have all of your tables registered within unitycatalog, you can go to any table and go to the quality tab and create a monitor. We have different types of monitors, including snapshot, time series, and models for inference and predictions. This allows you to understand how your data is changing over time, understand the drift of the data, and really kind of hone in on where there might be quality issues before your downstream users are reporting them to you. In addition to data quality, you would like to have just general observability into how your users are interacting with your data sets, how they're using the platform, cost and efficiency analysis. And so that's where our system tables come in. So with unitycatalog, you get a out-of-the-box system catalog that you can enable schemas in within your Metastore. And that will contain a collection of information of audit tables, budget tables, compute tables, to really get a full picture of how workloads are being executed within your environment. And for the account admins, we've actually taken this one step further. So it's great to have all of these system tables that are just plain Delta tables that you can query against with SQL. But the next step is always going to be creating a report on top of those tables to understand your usage. So we do have now a AI/BI cost dashboard that's out of the box that you can deploy directly from your account console to a particular workspace. That will show you your usage across all your workspaces or just for a particular workspace, so that your users can really understand what the usage looks like. And of course, once these dashboards are deployed, you can customize them however you like, but this gives you a starting point to answer some of the common questions that users have about budget. In addition to tracking and viewing a report, we also have introduced a budget feature. So within your account console, this allows you to configure a budget that could be tracked for a particular workspace or a particular subset of workspaces, and even allow you to filter the what's getting attributed to that budget using tags. So any workloads or compute running with that particular tag could then get rolled up into that budget, which you can receive alerts on. So let's take a quick demo of these two options here. So if I go into my account console here, I'm an account admin. So for that workspace admin console, this is the full account console that Suzanne had referenced at the start of the presentation. And you'll see a usage tab now. And within this usage tab, you'll have two options. First, you'll have the consumption here, and you can go ahead and click this setup dashboard link. And then you can select the workspace from a dropdown that you're interacting with. You can deploy this dashboard, that out-of-the-box dashboard, to that workspace. And you can configure whether or not it tracks all usage or just usage of a single particular workspace. In addition to that consumption, we also have budgets here. So the budgets give you a great way to track for a particular budget how much your spend is. So within the budgets tab, you can just click add budget here, give it a name, specify the amount, go through and select whatever workspaces you might want that compute to be rolled up for to track the budget that you're working towards. So this can even track compute across workspaces. And then you could even add in some particular key value pairs for different tags that you might want to track to have rolled up into this budget. And then you can set up an alert so that you can receive a notification if you've exceeded that budget for your monthly spend. So let's take a look at the dashboard that gets deployed once you are setting up the dashboard here. So I've already deployed this dashboard to a workspace. And so once this dashboard gets deployed, this is what it looks like. You can filter by time, you can filter by workspace, you can change the view of how you're viewing this data by week or by month. You can look at the different breakouts. So you could view spend by workspace if you're viewing this information across all workspaces. You can view your spend by a particular SKU. And all of this is built directly on top of those system tables that you get out of the box. So this information allows you to really easily see, for example, how's my spend across jobs changing over time? It also gives you tag analysis. So you can filter by particular tags here. We have a lot of mismatches, but you can see here I've got two budget tags here that allow me to see what the spend is associated with those tags. This also gives you a great way to track compliance. If your users, for example, are running workloads that don't have tags, you could start to identify where those workloads are coming from, do some enablement to make sure everything is being tracked appropriately. And then finally, you also get information about the jobs here. So we can see over time what the spend of particular jobs are, and maybe identify jobs that need to be optimized. So here we have a relatively new job that came up that's using a lot more compute than all the rest of them. So maybe we want to narrow in our efforts there to reach out to that team to help them better optimize that job and keep our costs under control. So now that we have our data available, our users are interacting with it, we can see how we're consuming this. We do also now have unitycatalog as a open source with open source APIs, so that you can even interact with all of the governance that you've configured across your assets using any other engines of your choice. So this would be interoperable, but it still respects all of that unified governance that you've implemented across your unitycatalog objects. The governance piece is really important here. We want to make sure that this is simple for you to interact with all of your unitycatalog objects if you choose to do so from other engines. And so one way that we do that is with a new Databricks developed feature called credential vending. So before this Databricks feature, you might have had cloud policies that grant direct access to storage, but then you'd end up having to configure that for all of the different engines that have to interact with that particular data. So outside of Databricks, these other engines might be interacting with these tables, and you have to kind of understand what all the policies are, scale them, and like replace them each time for each new engine you might use, which can be really difficult. So credential vending solves this problem here. So here, UC is kind of the vehicle with which your engines are able to get just-in-time access to all of your Unity catalog objects. So this allows a unified layer for interacting with these tables to kind of respect all of the governance that you've put in place for your Unity catalog tables. So Unity catalog with credential vending is in preview. But with this feature, you're able to use any engine across your client ecosystem. It allows you to interact with your data and AI assets in Unity Catalog, and it even supports additional formats. For example, the Iceberg REST catalog APIs with Uniform. Unity Catalog open source right now is in our V1 deployment. We're continuing to iterate and add additional APIs and expand upon them. This is a collection of the features that are available with the Unity Catalog open source APIs today. But stay tuned as a part of our Unity Catalog open source community to get the latest on all the new releases that are coming out and all of the features that will be available there. So let's get into a demo here to kind of see what this looks like. So I'm just going to pull up a terminal here, and I'm going to use DuckDB to interact with my Unity catalog assets. And so I've just got a little notepad here to take some of the code that we need. So what I'm going to do here is I'm going to install two libraries here, Delta and UC Catalog, and then I'll load those libraries. And this UC Catalog one is the one that's going to allow me to interact with that same Unity Catalog that we've been interacting with through Databricks. But I'll be doing this directly from my computer, not using any Databricks SQL warehouse or any other clusters. I'm just using my own like DuckDB setup here. So here I'm setting up that Unity catalog so the UC Web one we've been looking at through the whole webinar. I'm leveraging the UC catalog library here to configure this. One other additional step that I did here just before the webinar was I configured the credential endpoint, like the token for how I can interact with Unity Catalog using credential vending. And then the last step here is just to select some data from my table. So no connection to like a compute layer from Databricks. I can just use this configuration and the open source Unity Catalog APIs to interact directly with my 3-level namespace for those UC tables. And right here, we'll be able to see that this is going to give me back the actual data from this particular table. So you can see that all of that hard work that you put into configuring your Unity catalog governance is something that is not locked in. You can use this in the wider ecosystem across any engines and still get the benefits of all of the security that you've spent time implementing. So as I said, we're continuing to release additional Unity Catalog open source APIs. So you can learn more on our website. We would encourage you to follow on LinkedIn for the latest updates, to participate in GitHub discussions, and to join our Slack community. And if you're a Databricks customer today, you can contact your Databricks account team to get started with credential vending and Unity Catalog open source. So one additional feature, aside from our open source APIs for consuming your Unity Catalog assets, are also data sharing with Unity Catalog itself. So Unity Catalog can help you share data within and outside your organization very simply. One way that you can do this within your organization is with AI/BI Genie Spaces. So this is a way that you can curate a collection of data sets, and your users can ask questions of those data sets in natural language. So they don't have to have a particular dashboard set up. It leverages all of the rich metadata that you've already curated for your Unity Catalog objects. And it respects all of the governance that you've applied on top of those Unity Catalog objects. So this is a great way to kind of allow users to be empowered to kind of consume those UC assets on their own. Like I said, it's a no-code experience. It just uses natural language, and you can even customize this with additional instructions for accuracy and monitor user feedback about the responses they're getting back. Another way to share data is with delta sharing. So delta sharing leverages Unity Catalog, and it allows you to share across platforms with an open delta sharing protocol. And the data consumer here can be Databricks, but it doesn't have to be Databricks. You can share with any compatible client for your external users to consume those data sets securely. And it's sharing data without any replication. If you're curating assets, and some of those assets might be available for other data consumers aside from specific partners or customers, you may also be interested in our Databricks Marketplace. So Databricks Marketplace is an open marketplace for all of your data and AI assets. It allows you to publish as a data provider particular assets that users can browse and consume. Because it leverages delta sharing, again, no replication is required of the data. And data consumers can come into the marketplace, discover those assets, get value from the data faster. And again, there's no vendor lock-in here because it's leveraging delta sharing. You're able to consume these assets from Databricks, but also from other platforms as well. Another feature that's powered by delta sharing here would be Databricks Clean Rooms. So this is a privacy-safe collaboration space for data and AI. So again, it's cross-platform, cross-cloud support. It's designed specifically to manage complex workloads at scale. And it gives you a flexible environment, again, privacy-safe, to do native support for machine learning with Python. So we can go into organization and access patterns, but just before we do, I'm going to jump one more time back into our demo environment here and just show a little bit of that sharing interaction that we saw. So the first thing that I'd like to do is just highlight the marketplace. You can access the marketplace directly from your Databricks workspace here. You can browse for particular types of assets. So you'll see it's more than just data that's being shared here. You can share files, models, solution accelerators. In this case, I looked for a particular table that we wanted to work with. And then you can also check and see if there's assets on a private exchange, whether or not these assets are free. And you can search for particular providers to look at exactly what assets they're offering. So this asset here is a data set that includes zip code metadata, population information, demographics information. And so this data set would be a great way to augment all of the Medicare data sets we have. It'll give us more information to complement all the details we have about subscribers and providers within our data set. So I've already added this catalog or this data set into Unity Catalog. And if we open this, we can see this directly within the same interface here. So here's the catalog that Suzanne had walked us through earlier today. This is the catalog in my org, in my Metastore. But here you can see the shared catalog. And so that creates a catalog just like anything else. It creates the schemas here. And then I can click into particular tables, and you can view all the same information about these shared tables that you do with your, the in your org catalogs that you've curated. So the next thing that I'll do is I'll go into a Genie room so I can start asking some questions about all of this data, my federated data, my catalog data, and my shared data here. So I've created a Genie space here, given it a name. We've selected a Databricks serverless SQL warehouse that it's running against. And then you can click through here to go through your catalogs and select the tables that you'd like to add. So you can see here I've added 4 tables from my Medicare schema from my Unity UC web catalog. I've also added my federated table, so the Snowflake table. And then I've added this Delta shared data, the zip code demographics information. So this shared catalog. So we have federated catalog, shared catalog, and a standard catalog here. And remember that we do have fine-grained security applied to the geography table and our provider table here. So once I set up this Genie space, I can come and start asking questions about the data here. So we can ask, what tables are even available in this room? How are they connected? How should I start interacting with them? And then Genie is going to leverage all of that metadata that we have about the tables here to give me a human readable summary of all the data sets that we're working with. And I'll just do a little bit of cheating here to jump over and grab my pre-typed questions, just to save some time. So one question we might ask is, who are the top 5 prescribers by name and NPI with the most claims? So Genie is going to parse this question. It's going to give you a little bit of a summary of how it's going to retrieve the answer here. And then it's going to generate the code that would give us this answer, execute the code, and using that warehouse that we configured, and give us back the response. And so here you can see that this, in order to get this data, we had to go against our federated data set. It joined it against our standard data set, and it even respected the column masking that I have. Because remember, I was not a part of those groups we selected, and so it masks that data for me. So this gives you a secure way to browse that information. And we can ask another question here about the total drug cost for beneficiaries over 65 years old by state for a particular year. So you can see you can start to get pretty complex with the questions that you ask here. Again, it's leveraging all of that metadata, and it respects the row filtering that we had on top of our geography table. So it's getting all that geo data, but I only have access to 3 states here, so those are the only ones I see. I can also ask a question here, what is the total population by state? And what it's going to do here is the same way it goes against the standard catalog and the federated catalog. It's actually going to retrieve information from that shared catalog. So this is coming from the complete data set that we have from our demographics information. And then finally, I can ask a question to ask whether it can join this demographics data from my shared catalog with the previous query to show me the per capita drug cost by state. And so what it's going to do here is it's actually joining not just that shared catalog data, also against my standard catalog. It's respecting the row and column level security, and it's giving me more of a complex calculation of the per capita drug costs here using that demographics information. And then I can even auto visualize these results to get back a graph of the information that we see here in the table. So you can see that this gives you a great way for your users to start consuming the data sets that you have securely, regardless of whether that's federated data sets, shared data sets, standard data sets, whether the data sets have row and column level security applied, you can interact with that in a very clear and easy to use way. So we've seen kind of the full scope from setting up our storage credentials and our connections at the very beginning, to consuming our data using natural language, using open source APIs, to looking at all the observability patterns. And so we just wanted to kind of round out today's presentation with some organization and access patterns as you're getting started with setting up your Unity Catalog Metastore for your workspaces. So some of the top questions that we get are, how many catalogs should I configure? What are common access patterns to catalogs? What data isolation controls do I have? And when should I use those different isolation controls? And how should I design my multi-cloud or multi-region deployment? So we'll start with the Unity Catalog isolation features because we do offer you a collection of both logical and physical isolation levels of configuration. So at the very top here, you see delegation of management. So even though you have your Metastore admin, you can also designate particular people or teams, so users or groups, to be owners of particular catalogs, which really allows you to have that single unified view of all the catalogs across your Metastore from your Metastore admin. But then it also kind of empowers distributed business units to have full ownership of curating their own data products and then being able to actually share them with other business units within your organization. The next level of configuration that we have is workspace to catalog binding. There are some cases where our data should only be accessed in designated environments or workspaces. And so you can actually bind catalogs to particular workspaces so that only that workspace can read and write to that catalog, or even that workspace can only read that catalog. And then finally, we have storage isolation. So there may be requirements that you have where data should be physically separated in storage. And that might mean like separate storage accounts in different like Azure subscriptions, for example. And so that's where those levels of configuration that Suzanne had demonstrated at the start of the webinar come in. You can define a catalog to belong to a particular location, kind of overriding that Metastore storage configuration if you've set that up, because it is optional. Just as you could have multiple catalogs kind of managed within the same storage location. So when you put all this together, what it might look like is having catalogs writing to particular storage locations, business units owning particular catalogs, and then those catalogs being bound to particular workspaces. And so you can see with workspace B here, it has access to catalog 2, which is stored in location Y, but it also has access to catalog 3, which is stored in location Z. So you can get really complex with the levels of isolation here for each of the different data products that you need. So if we think about kind of this centralized and distributed ownership that we were referencing, here's kind of a practical example of what all that might look like put together. For your Unity Catalog Metastore, you might start out with like a central dev, staging, and prod catalog. And this might be something that's managed by your central IT team. They're the ones who are using and creating assets within these catalogs. But then they might actually grant use permissions or select permissions or browse permissions to distributed business units to be able to consume maybe just the assets within the prod catalog. Those business units then might want to use those assets to create their own data products. And so your first business unit here might even create their own dev, staging, and prod catalogs. And then that business unit would become the kind of owners or managers that are using and creating assets within those catalogs. But again, you get that distributed consumption. So your other business unit might be able to use or browse those prod data sets there. And maybe your central team can also use and manage or use and browse those production data products as well. And similarly for your other business unit, with any catalogs that they create, in this case, we're just showing dev, stage, and prod, they're kind of managing and curating all the data products within that particular catalog, but then they're still allowing distributed access to other business units and the central team within their organization. So putting this all together, what this might look like is with your Metastore, you could have a collection of catalogs, whether those are dev, staging, and prod, or business units break out with their own dev, staging, and prod, or maybe just one catalog per business unit. These catalogs can be accessed from multiple workspaces. So maybe you should only be writing or accessing your prod data from your prod workspace. But from your dev workspace, you can access multiple catalogs. And then for those workspaces, your groups have access to particular workspaces. So your analysts are always going to be consuming those production data products that you create, whereas your developers and testers might be a little farther upstream interacting with your dev or staging workspaces here. As a general best practice, separate your catalogs by responsibility and kind of makes things a little bit easier. So that might look like creating separate catalogs for development environments, so like dev, QA, and prod. It might look like creating separate catalogs by business units, so maybe a catalog for central IT and a catalog for finance or sales. And then, of course, your sharing and foreign catalogs are going to be created separately as well. Use workspace catalog binding where required. One use case that I typically see is giving your dev workspaces read-only access to your prod catalogs. It's a very common use case for data science, where your data scientists might need to do sampled reading of your production data. And if they have that workspace catalog binding with the read-only mode set, then they're able to read that production data to do their development for any data science work without having to replicate your production data back down to your lower environments. With all of these kind of guidelines, still the foundation would be create the minimum catalogs required to meet your team's isolation and ownership requirements. So if you have a use case where everything can just go in one catalog and you're separating things out by schema, that's great. Don't create more catalogs than you need. One other piece here is how you're able to interact with Unity Catalog. And so your compute now that you can interact with for Unity Catalog will be defined by the access mode. So the shared access mode is shared clusters that multiple users can work on. You don't have to configure like any hard-coded service principals or IAM roles directly within that cluster. All of the direct management or direct access to your storage containers is all configured within Unity Catalog. So those are settings that you might have set in kind of those legacy clusters that you wouldn't use anymore and aren't governed by Unity Catalog. So with shared access mode, multiple users can access it. Don't need to configure those like service principals or things like that directly within the cluster. You also have the single user cluster. So a single user is the dedicated user that can use that cluster at any given time. In preview, you'll have the assignment to a group. So that single user you're assigning to doesn't necessarily have to be one user. It could be one group, which is then a collection of users. This mode also supports R as well as Databricks ML runtimes. And fine-grained access control is in preview for these single user clusters. And then, of course, you have your SQL warehouses here. Multiple users can work on your SQL warehouses, but it is SQL only here. As a best practice, start with shared clusters or SQL warehouses as your default compute, and just fall back to your single user clusters in case of limitations or if there's specific requirements. And always make sure, like, if you're developing on a shared cluster, then deploy using that same access mode into production for consistency. You don't want to start building something on a single user compute and then deploy on a shared compute in production, because there might be discrepancies on what's supported between shared access mode and single user access mode. For cross-cloud or cross-organization or even cross-region access, Delta sharing is the way to go. So if you have metastores that are deployed across multiple regions, maybe one for EMEA and one for North America, you can share data and information between those regions using Databricks to Databricks Delta sharing. Similarly, if you want to be able to share your data with other cloud providers, so for example, from Azure to AWS, you can do that with Delta sharing. Or if you want to share with other partners, you can do that with Delta sharing as well. Best practice, keep a single region Metastore, like that single Metastore for all your kind of like software development lifecycle and business unit scopes, kind of like all together. So typically, if you can avoid it, you wouldn't want to have, dev and prod catalogs deployed in one Metastore in like Northeast and your staging catalog deployed in a separate Metastore in the West. Keep all of those together and use Databricks to Databricks Delta sharing between cloud providers and regions. So we're just wrapping up here. For next steps, if you're using if you're using Hive Metastore today, use unitycatalog labs project to upgrade your unitycatalog framework. This is a labs project that will give you an assessment and then allow you to give you recommendations on how to complete your migration. Today, we went through a lot of examples, but we do have demos that you can run to get started with Unity Catalog within your environment. So Lakehouse for IoT and predictive maintenance is one of those use cases. We have the link here, which will be shared with the deck, that you can get up and running from files all the way through to dashboard directly within Unity Catalog and get a feel for everything we've talked through. We also have the Databricks system tables. So this demo leverages system tables to create a dashboard. It shows you sample SQL queries that you can use, as well as not just against the budgets, but against the objects you have. So who's creating tables, who's creating volumes, how many of them have been created. So this demo is one that, again, you can just install directly within your workspaces to get started. And then you might be interested in additional demos of Unity Catalog. We've got a lot of bite-sized demos that you can kind of consume at your leisure, as well as a getting started guide here. And then finally, we do have our data analytics and AI governance ebook, which is a comprehensive deep dive for how to build an effective governance strategy for your data lakehouse. And I just want to thank everybody for attending today's webinar, for all the great questions, and thank our wonderful subject matter experts and our Q&A support team for answering all these questions. I know we've got a lot coming through, so I really appreciate the help here. The deck will be shared, the recording will be shared. I don't know that we'll be able to close out all of the questions before the end of our session here. But we will get the report and do our best to kind of follow up on those as we can. Yeah, so thank you so much for attending the webinar. Let me just check in with the Q&A team here and see if there's any questions that we should address live on the webinar, since we have just a few minutes left here. Let's see. Not seeing anything highlighted just yet from our Q&A support team. So hopefully, everyone was able to follow along with today's webinar. Feels a little bit more confident about all the different components that you have for Unity Catalog, how they fit together, how you can design your own governance strategy with Unity Catalog to fit your company or your business's use case and requirements, your governance requirements, as well as your consumption requirements, so how all your downstream users might interact with these data products. And I'll just check in one last time here to see any questions. Okay, let me check the Q&A chat here. Okay. So one question we had was, what information is Unity Catalog using to determine the lineage? Which is a great question. So when you, we talked at the end about the compute that you're using to create and interact with all of your Unity Catalog objects. So because we have this single unified layer of all the files we're reading, all of the tables that are getting created, and all the upstream tables that are used to create even more downstream tables, we're able to leverage all of that information to compile that complete lineage picture. And that lineage is also available for you to query against and report on within the system tables in the access schema as well. Let's see if there's another question here.
Pamela, there's a question on what is vector index?
Got it. Okay. Yeah, so vector index is a like a index that you can create on top of your unstructured data or any data set to create a table of embeddings so that you can leverage them for other RAG applications. So for example, you have a question that might come in, like a natural language question for a Gen AI chatbot that you might be building. You want to be able to complement the answer. So you could just ask that question directly against like any large language model and try to get back an answer, but you'll likely run into accuracy issues. And so what you want to do is you want to inform that language model and pair other resources from your data sets, so like your particular data, with the question being asked to allow the large language model to create a more accurate answer. And so vector index is what allows us to very quickly identify what underlying data sets should be leveraged as those resources that get used to create more accurate Gen AI responses. I see a couple more questions here. So what's the motivation for the shared versus single user mode clusters? So great question. So the shared clusters are guaranteeing isolation between users, all using the same compute. And in order to guarantee that isolation, there is some kind of limitations applied to what those users are able to do on that compute. That allows us to ensure that you'll always have security there. For the single user clusters, because we have some limitations on what they can do with shared clusters, which we're continuing adding releases to build in more functionality there, but because it's not all the functionality, now you have the single user clusters that gives that expanded role because it's only ever a single user leveraging that cluster. And last question here, how do we handle cluster upgrades in case of an existing UC implementation? So I think the question being asked here is, let's say you have an existing Databricks workspace that's running off of the legacy clusters, using Hive Metastore maybe, and you want to be able to upgrade those workloads to Unity Catalog. You can one way to approach that would be using that UCX Databricks Labs project that we highlighted in the deck here. It'll do an audit of your workspace and the assets that you have there and make recommendations on the best path to uplift them to Unity Catalog so that you can start leveraging those workloads using the Unity Catalog compute in the future. And I think that might be all the questions that got called out here. So again, I want to thank everybody for attending today's webinar. Hopefully you found this useful. We encourage your feedback. Let us know what you want to see in our future Unity Catalog webinars. And yeah, I hope everybody has a great rest of their day, and appreciate the time and the great questions here. And thank you again to our wonderful group of SMEs and Q&A support. You know, they've got a lot of questions that came through today. Thanks, everybody.